All right, guys, this is graphing linear inequalities and writing them with interval notation. So here are some general tips. When graphing intervals, we're going to use an open circle for less than or greater than. An open circle would be like that. Okay, open circles also go with parentheses. Okay, use closed circles, so just like a filled in dot, if you have less than or equal to or greater than or equal to. And so those will be brackets instead of parentheses. You also may see that this would be a dotted line and this would be a solid line. Why do we use closed circles or brackets if you have less than or equal to or greater than or equal to? Because it includes the number you're stopping at. Okay? This one does not include the number you're stopping at. Good? For interval notation, the general idea is how far left is that answer going and how far right is that answer going on the number line, okay? So I always graph the interval first before doing the interval notation. So I get x is greater than or equal to 2. I graph that on a line and then I write it in interval notation. We use parentheses for less than or greater than. We also always use parentheses if you ever have infinity or negative infinity. So infinity and negative infinity always get parentheses. Less than always gets parentheses. Greater than always gets parentheses. Less than or equal to gets brackets. Greater than or equal to gets brackets. Okay, so it says write the inequality using interval notation and illustrate the inequality using the real number line. You are welcome to use Desmos for this. Let me show you what that would look like. So you've got your graphing, you've got your graph, you're using your graphing calculator. It says x is less than or equal to 2. So you can see how that showed up as a red line right at the 2, and then everything is filled in greater than 2 or to the right of 2. That means that the answer is any number that is 2 or that is bigger than 2. Good? So that's a way to check your answer using a graphing calculator. X is any number bigger than 2, and X is equal to 2. So I will create a number line. You can start it anywhere. I'm going to say that this is 2, right? And X is, it has the equal symbol. So that means it's going to be a bracket and it's bigger than 2. What is bigger than 2? The number 3. So that means it's going to be going this way forever. It includes 2. So I'm going to include a bracket. So that's how I would graph on the real number line. X is greater than or equal to 2. Now that I have it graphed, I used a bracket, right? Instead of parentheses because the bracket is for equal to. Now using interval notation, I started at 2. What did I start with? I started with a bracket and it goes on forever. Forever means it's approaching infinity. Infinity always gets parentheses, never a bracket. Good. So x is equal to 2. That means we start at 2. X is greater than 2. That means it goes on forever in the right direction, to the right. Good. All right, here we have x is less than 5 and x is greater than or equal to negative 5. So we need negative 5 on here. 4, 3, 2, 1. So that would be 0. And that would be positive 5. Good. All right, let's look at what we've got. We've got x is less than 5. Less than is parentheses. So x is less than 5. Less than 5 would be this 4 right here, right? X is less than 5. Less than uses a bracket. Or sorry, uses a parentheses and not a bracket. And X is greater than or equal to -5. I don't know why I drew one I wrote above and one I wrote on the line. So we've got a bracket over here. Try to make that a little clearer. We're starting at -5, but including -5. We're ending at 5, and we're not including 5. Good. And then when I need the interval notation, it started with a bracket. The bracket was at -5. It ended at +5, and it ended with a parentheses. So I can just recopy it down. X is less than 5. X is greater than or equal to -5. Fill in everything in between. Here we've got -7 is greater than X. I like to write it this way, so I'm just gonna -7 is greater than X. X is less than -7. Those are saying the same thing, right? So I'll find -7. X is greater than -7. Greater than is in this direction forever. It doesn't include -7, so it's going to be a parentheses. So my answer is parentheses -7 to infinity for number 4. All right, we may also need to solve linear inequalities. In general, solving inequalities works the same as solving equations. The main difference is if you multiply both sides by the negative number or you divide both sides by a negative number, you have to reverse the inequality, so you flip the sign. You might write the answer in inequality notation on a number line or in interval notation. So here it's asking us to solve the inequality and then graph it and use interval notation. So graphing and using interval notation is just what we did for 2, 3, and 4. X plus 7 is less than 5. 7 is being added to X, so we're going to subtract 7, and we get X is less than 5 minus 7 is -2. Here's -2 on my number line. X is less than -2. Less than -2 means it's going to go that way, right? It does not include -2 because it's the less than symbol, so I'm going to put the parentheses. And it goes on forever in that direction. All right? Forever in that direction is a negative infinity, right? It's going forever, so it's infinite, but it's in the negative direction. It ends at -2, and it ends in parentheses. So that's interval notation. X is less than -2. X is less than -2. X goes from negative infinity to -2. Sorry. Here we've got 8x minus 2 is less than or equal to 7x plus 5. I'm going to get all of the x's over here and all of the constants over here. 8x minus 2, my constants are moving over there, so I'm going to add 2 to both sides. Now I've got 8x is less than or equal to 7x plus 7. I need all the x's over here, so I'm going to subtract 7x, subtract 7x. My answer is x is less than or equal to 7. Here's 7. What direction is less than 7? It would be over here with 6. It's less than or equal to, so it's going to be a bracket. It's going to go on forever. So it's going to start at negative infinity. It's going on forever. The negatives always have a parentheses. It's going to end at 7, and it ends with a bracket. Good? All right, I might need more space. So that's -5x plus 1 is less than or equal to -6x plus 8 for number 8. I'm going to solve by moving all of the x's over here and all of the constants over here. We're adding 1, so I'm going to subtract 1, and I get -5x is greater than or equal to -6x plus 7. I'm going to move that negative 6x by adding 6x to both sides. And what I get is x is greater than or equal to 7. How would I graph that? Start with 7. Greater than 7 is going to be over here. Equal to means I use a bracket. And it goes forever, right? So that means I have a bracket at 7, and I go forever. Infinity gets the parentheses. Number 9, I have x divided by 3 is greater than or equal to 5 plus x over 18. So first of all, I want to get rid of these fractions, right? Okay. If I want to get rid of fractions, I'm just going to multiply everything by the biggest denominator. So I'm going to take this, multiply it by 18, take this, multiply it by 18, take this one, multiply it by 18, because I have to do it to every part of it so that it remains equal. So that instead of x divided by 3 times 18, it's going to be 18x divided by 3 is greater than or equal to 5 times 18 is 90. 18x over 18. Now we know, right? The reason we did it was to simplify this. So we know we can simplify this. Can we simplify 18 to x over 3? You can just take 18 divided by 3, it becomes 6. So luckily, that gives us 6x greater than or equal to 90 plus x. Good. We multiplied everything by a positive 18, so we don't need to change the sign. We change the direction of the sign if we multiply everything by a negative. Okay. Now we have 6x greater than or equal to 90 plus x. I'm going to move that one x over by subtracting x. 6x minus x is 5x greater than or equal to 90. Now I'm going to divide both sides by a positive 5. And I get x is greater than or equal to 18. So that is x is greater than or equal to 18. Here's 18. Greater than means it's going this way, right? Towards 19. It's equal to, so it's going to be the bracket. And so my answer in interval notation is bracket 18 towards infinity. So from 18 and including 18 to infinity. Our last 3 examples use compound inequalities. The goal to solving a compound inequality is to isolate the variable in the middle, and you follow the same process as solving for any other equation or inequality. So anything you do to the middle, you do to the left side and the right side. Good? The only difference is you have to apply the same steps to all 3 parts of the inequality, to the left, the middle, and the right sides. Solve the inequality, graph, and express your answer using interval notation. So again, we've got 11, number 11, we've got negative 16, 4x, and 24. We want the x alone, okay? Negative 16 is less than 4x is less than or equal to 24. What is happening to x right now? It's being multiplied by 4. So to get x alone, we divide by what it's being multiplied by. Divide by 4. Anything I do to the middle, I have to do to both sides. So negative 16 divided by 4 is just negative 4 is less than x, which is less than or equal to 24 divided by 4 is 6. Good. I did not divide by a negative, I divided by a positive, so we do not need to change any signs. So our answer is negative 4 is less than x, which is less than or greater than less than or equal to 6. Let's draw our number line. Here is -4, 3, 2, 1, 0. Here's 6, I think. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Good. X is greater than -4. Greater than uses that and goes that way. Bigger than -4. X is less than or equal to 6. So we're going to use the bracket and go towards the -4. Good. Our final answer is parentheses, -4, 6 with a bracket. From -4 to and including 6 is our answer. For number 12, we have 13 is less than or equal to 4x plus 5, which is less than or equal to 33. Again, we want x alone. X is being multiplied by 4 and 5 is being added. So we're going to subtract 5, subtract 5, subtract 5, because anything we do to the middle, we have to do to both sides. 13 minus 5 is 8, less than or equal to 4x, which is less than or equal to 33 minus 5 is 28. Let me make sure. 33 minus 5 is 28. Good. Now, x is being multiplied by 4. We're going to divide it by 4, divide it by 4, divide it by 4. 8 divided by 4 is 2. That just leaves us with x. And then 28 divided by 4 is 7. So our answer is 2 is less than or equal to x, which is less than or equal to 7. Here we've got 2 and 7. X is greater than or equal to 2. X is less than or equal to 7. So we've got that as our final answer. Number 13, we have 40 is less than or equal to 20x minus 30, which is less than 60. X is being multiplied by 20 and 30 is being subtracted. So we're going to add 30, add 30, add 30. 40 plus 30 is 70, less than or equal to 20x, which is less than 90. Now we're going to divide by 20. And if you put that into your calculator, 70 divided by 20 is 7 halves, is less than or equal to x, which is less than 9 halves. And what is 7 halves? Well, 6 halves would be 3, right? So it's between 3 and 4. So if this is 0, 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves starts right here. It's less than, or sorry, x is greater than or equal to 7 halves. And then 8 halves, 9 halves. It's less than 9 halves. So it's between 3.5 and 4.5. And we'll write this as bracket 7 halves to 9 halves. And that one closes like that. All right, guys, that is it for solving inequalities.